All right. Hello. Welcome to the fourth episode of this SC30 Repro board assembly series. I did mess up the stream settings a bit. I tried initially to make this something that was scheduled on youtube.com, and then I tried to use OBS to connect to the stream, but I could not make that happen. I got errors, so I'll have to create a new stream. So let's see if I can send a link to share with others who may want to join. So let's see here. I'm gonna get a shareable link. All right, so hopefully the people who wanted to see this should be able to join now. Let's see here. There we go. All right. So the first thing I was gonna do, just as a warm-up, I realized as I was working on this that the board itself has these edges that came from the factory. At the very end there, there's actually not. Yeah, so this edge here is just something that was temporary out of the factory. And if you compare it to the original board, it doesn't have those edges. It cuts off clean out actually on this side. So if you see, it has these 3 wedges here. That's where it should fit in, where the board fits into the SC30 case. So I thought I'd just break this edge off so I don't forget to do that later. And I did that for one of the sides already, but I thought I'd do the other one live here. So let's switch to the close-up here. Let's grab these pliers, see if we can get this edge off of here. There we go. Came off nicely. So we don't need this anymore. Alright. So where we ended off last time is we finished off smaller donor board ICs and one UIC as well. There's one attached as well. And yeah, there's 2 over here. These ones. Near the end of the stream, I was using the soldering iron technique. I did run into some problems with heat transmission with the iron onto the legs, and I realized in hindsight that I should have gotten my flux out to actually make those joints work. Because after the stream, I went over these joints again, and I found a couple where the pins hadn't attached properly to the pads, especially let's see here, the edges here, like the edge pins hadn't attached at all on many of the chips, so I had to go back and add some more solder afterwards. So I'm thinking, for starters, I'd like to try the soldering iron technique one more time and use flux and see if that goes better. So I'm thinking we should do these 2 chips on the side here, and then for the large cluster of chips down here, I'm gonna try use the solder paste hot air technique again. to kind of demonstrate how you can use it at scale, so to speak, to get a whole cluster of ICs. So yeah, let's try that. Let's start over here. So we have two chips that sit on the side here. We have RP1 and UD1. So UD1 has the silk screen marking F240, so, and also the form factor is very unique for this one, so there's only really one chip that can fit on this one. TIT 013AS F240. But let's do the smaller chip first. So I don't know. Oh, hey Sinazite, welcome. Thanks for joining the stream. So we have to find what chip goes on that pad. Let's see here. So we have, I think last time I went over one of these chips, and there are 3 or 4 that are exactly the same. These 112SO300 chips. Most likely that those are not the ones that go on this RP1. Yeah, that's also one of those. This is the odd one out, so it's likely to be that one that goes here. Yeah, it's fun to have spectators, otherwise you just speak into the air. Thank you. And this is one of the 4. So those 4 are probably gonna go down into the cluster further down here. Okay, I'm gonna angle the camera down now so we can look at my desk, like so. While we do this. So just to be sure we don't put the wrong chip in the wrong spot, let's check our source of truth, which is the unofficial BOM. And as usual, it doesn't show up right away, so I have to switch to this. There we go. That should show up now. All right. So let's look for RP1 on this sheet. RP1. And not RP10, we want RP1. There we go. And that is a 22 ohm resistor network. It says right there. It's the RAS cos lines series termination. And the part number is 4816P 001220. And this one says 112SO402. So it doesn't really line up with what it says on the sheet here. And in fact, if you look closely, it may actually line up with one of these 4. Let's see, move it. There it is. Which part of this build do you think you are the most nervous about? Have you already done that part yet, or is it still to come? I've done the hard part, I'd say. All the big ICs, they have so many pins each, and they are the kind, I don't know the proper term for it, but they angle inwards, right? So it's so much harder to get a solid connection, or to be sure that you have a good bond with the pad. All the other chips are fairly easy, I'd say. It's just, you just gotta do it. But these large ICs, so for instance the FPU here, right? I went over that last night, double checked everything, and I found at least 3 pins that were clearly not attached to the pads at all, and it's ever so slightly out of alignment as well. So this side of the chip here, it kind of protrudes a little bit too much over its, like the outline where it's supposed to be. So it's ever so slightly more difficult to get a good bond on all these pins on this side. that makes me nervous, right? Same goes for the glue logic chip, like the really big one here. So many pins that could be not perfectly attached, and all of these large ICs. Plus, I'd say this NCR53C80, which I believe is the Apple sound chip, has quite a bit of corrosion on this side here. You can almost see it up here, like there's some green crust there. This chip is definitely one that's in the worst shape among those that I'm putting on here. So this chip may or may not work fully. Oh yeah, do the hard stuff first, for sure. And it also, these big chips are the hardest to solder if there's a bunch of stuff around them, right? For instance, this is what I learned from the Tech Night, is that we have this FPU here, right? The 68882. It sits right next to the SIM slots, right? So if you solder on these SIM slots here, it's almost impossible to get to this chip again, to kind of rework these joints without melting the SIM slots. So you really gotta do that first. And you also, if you look at the donor board, look at this mess. When I took off the original FPU, look at all these pads that I pulled. There was some pretty bad corrosion on here, so yeah, the pads and traces were definitely weakened, but I did, it was really hard. And these slots melted a little bit. So I don't want to repeat that. So anyway, 112 SO300. 112 SO300. Yeah, I'm not sure. So RP4567. RP456. Just want to compare what are the other chips. RP456, yeah, so RP1, 456, these are all supposed to be the same chip. Yeah, you should totally watch Tech Knight's video on his assembly of this board as well. It's really informative, although it's in the video format rather than the stream format, so there's less detail on everything that he did, but there's a lot of good info in his video, and it's linked to in the description. Anyway, so to at least get something done, let's solder the big chip on here, and as always we need to align the little hole or the stripe with a marking on the silk screen. So this very clearly should go right in this direction. And I actually see that one of the legs there is a little bit bent, so I'll probably fix that up. Be careful not to break the leg, because that would be sad. I think that's better. All right. So I'm gonna try let's solder one pad first, attach the chip, and then solder the rest. And this time I will use the flux to get a better heat transmission. Let's clean up the pads a little bit. Let's bust out the solder. Turn on the soldering iron is a good idea. Although I'm happy to say that this soldering iron heats up very quickly. Actually, I forgot. I said last time I would try a different tip. I think I'm gonna try a different tip. This is a little bit too large to solder these small chips pads. So since this is heated up now, it'll take a minute to cool down, but I usually use my pliers to pull the tip out. Oops, not good. Oh, hi. Stay here. And I have some more tips lying around over here. Yeah, there are a lot of good, fairly good, cheap soldering stations these days. This one I have here cost me a little bit more. I think it was just under $100 with tips and everything included. So I don't like to use too small tips because you don't get very good heat transmission. I find it harder to get heat onto the board. So I'm gonna just do this slightly smaller one, and it's pretty gross right now, but I wipe that off. There we go. So one problem, I think it was weird. They sent me tips that don't really fit this handle, so they don't really screw in there very thoroughly. They just kind of hang on to the tip there. So yeah, sometimes it kind of slides out a little and loses contact with the electronics inside. Okay, let's wipe off the old solder. So that's pretty nice and shiny. Look at that shiny tip. So there's a little bit of solder on there. Maybe you want to add a little bit more. I should turn on my fan now because to avoid fumes. This is pretty large chip. I'll probably just hold it with my fingers like this. Might not be the best idea, but I think that'll be okay. Alright, it's on there. It worked out fairly well. So this time, okay, I guess it's not super perfectly aligned. Okay, let's put a little bit further on this side, just to make it look nicer aesthetically. Alright, so I'm gonna use this cheap no cling flux that I got off eBay from some guy who makes these. And the name of the store is right there. I don't know if it's possible to focus on that. It says Slavin Fashion Art, eBay. Alright, so let's apply a bunch of this flux right there. Okay, so this is the hard part. Trying to get good shot while doing the job. I think those joints look alright. You have the same flux? Yeah. It's served me well. I have one more of these little squeezy bottles, and I've almost used up the first one. This is pretty easy. This is not too hard. wipe off excess solder. Clean up the joints a little bit. I think that looks pretty solid. It should be a good joint bond there. See, small solder pearl over here. Actually, is that on? It's probably some solder on a via there, so it's good. This here we'll be able to clean up. Oh, that's also a via. Okay. So that chip is on there. Pretty good. I may want to. So this, the drawback of this flux is that it has this. You see this white residue, some kind of salts, you know. So you may want. It's good to do some cleaning proactively. I wonder if my LED light is on too brightly. I'm getting a lot of flare. Maybe that's better. Okay, so we have this one more singleton chip. 112 SO402. 11SO402. So I don't know if there's a good one-to-one match there. So yeah. So by the way, this may be obvious, but the silk screen markings of RP1 of course refers to resistor pack, right? So these are resistor pack ICs, and I believe these are all the resistor pack ICs that I have here. RP789. P7 is a 02102. Yeah, so obviously the last 6 numbers indicate the rating, right? So it's 02102 maps to 1 kilo. 02221 maps to 200 ohm, and 01220 maps to 22 ohm. So I guess one thing we can do is see if we can measure the resistance on these. I don't know exactly how they're wired inside. SO402. We can try it. Oops, sorry about that. Bust out the good old multimeter. Put it to resistance mode, and I assume that input would be at pin 1, and pin 1 is always the one that's next to the dot or just below the stripe. So let's see what happens if we measure the resistance. Okay, so between this is pin 1 and pin 5,
we are getting 2 kilo ohms. So SO402, 2 kilo ohms. So that doesn't necessarily match with either of these. I don't think the exact resistance is super duper important, but it's good to be accurate. And this that ends in 300 between pin 1 and pin 5. I'm getting mega ohm readings, 10 mega ohm. That doesn't make sense either. I'm not getting any readings in this one. I wonder if these... Oh, no, that's... So between pin 1 and pin 8, 9, I think, there was... Yeah. Let's just to make some progress. I'm sure. I'm pretty sure that these will be fine, and they go into, you know, match whatever the spot that I got them from, which is basically let's see here. I know that the chip over here was unscathed, and the chips over here were unscathed. The RP9, RP8, and RP7. So I know for a fact that they came from these spots. Everything else that sat next to the battery here was completely ruined. Oh yeah, these are all from the parts board. Yeah, from the donor board. But at least start out accurately. Let's install the brand new parts instead then. So we have some diodes. There's at least one diode that goes here by the battery here, and in some other spots. Some more diodes. IC multiplexer. SN74F258D. Okay, let's open that one up. This one is easy. It's easy because if you look a little bit further down, there it says 5F2558 right there on the silk screen. Ta-da! New parts. Yeah, new parts are nice. So let's do those first. So for ECO assembly, I should probably do it like, or actually, so I can show off what's going on. Let's do it. I have to do it upside down. So this is these 6 chips right here. So this is where I want to try to do the hot air method again. Let's see how that works on these little chips. So I'll turn off my iron. Bring up the hot air station. So my friend Eric Helgeson gave me the advice that I had the little holder arm upside down. So because the nozzle is supposed to be held in an angle upwards for the auto turn off feature to work. So let's do that. So I've had my solder paste out of the fridge for a few hours. This should be ready to go. Pull this stuff out of here. Toxic as always. I have to look at the dead fish in the wilted tree every time to remind me you don't want to put this in the trash. Alright, so let's go down the line here, F258. So the lesson learned from last time was that you don't want too much of this stuff because it's going to be a mess to clean up, but it's really hard to get small amounts of this syringe. I don't know if I'm using it wrong. Get over here. Right, so we got some solder paste on there. It's not beautifully, but let's see if this. It might be an interesting experiment to see how well this will spread out by itself when we apply heat. So let's try this for now. So let's bust open this little tube, pull the edge off, pour a few chips out. Let's put them over here. So we need 6 of these guys. That is 4, 5, 6. Alright, stop. So I always order more than I need. The paste have solder. Yeah, so this is solder paste, literally. So this is liquid solder, and it's what does it say? What are the chemicals? I think it's silver, rosin, subric acid, silver, and I can never read this word, stearamide, but its chemical name is ethylembris and enebis. Yeah, so the shiny stuff is probably silver. So, but anyways, I needed 6. I bought 10 of these. So the interesting thing about this solder paste, it says on here, it says low temperature, which means that it will melt at a much lower temperature than regular solder, which is something worth keeping in mind. It makes it easy to rework the parts, but it also make it then easy for parts to pop off if you are doing other stuff nearby with heat. Yeah, sure, I will add links. I've added links to the other videos, but I can keep adding links if it's helpful. Alright, so let's pick and place these chips. The stripe is on that end right there, which means that we want to put that stripe towards the little marking on the silk screen. Like so. And so. I mean, I don't even know if this solder paste is the right tool for the right material for this board, this kind of board. I've used it a couple of times on other smaller builds. Oh yeah, this will totally work the first time. And I'm not jinxing it. Okay. So, yep, the solder is kind of all over the place. Let's see what happens when you put some hot air on this, if it's gonna... Because I know that with smaller components, so the forces of the chemical and physical forces are gonna be pushing them into position sort of naturally. But we'll see what happens with these ones. So what we want to do is to have the lowest airflow possible and the highest temperature possible. This this hot air rework station goes up to 450 degrees Celsius. That's what I will be using. Alright, here we go. Applying heat. Come on. Maybe I need to be closer. Yeah, so this doesn't look great. I'm not sure. Should I do it closer? Maybe that's it. Yeah, I need to be closer. Really. I think it's pretty clear that you need to have the solder paste sort of more evenly spread in the first place. Okay, so this one is a little bit out of positioning. Yep. So this is not where. Oh, I forgot. I should have cleaned the pads first. Don't think that would have made a huge difference. But yeah, this is not a great result. Uh, Luckily, these are always easily improved with a little bit of iron work. But I wonder why these were so bad. Um, Here we go. So yeah. Yeah, I agree that this is not a good example. It worked better a couple of days ago when I did the big chips. So still, there was a lot of rework with those as well. But it's not bad in the sense that you get a good like it's a good oh where am I shooting? It's kind of like a good start. So I don't think it's a complete bust. But but this is definitely not the best demonstration for how it should work. Hmm. This one here is not it's not having enough solder. That's better. Okay. I think those actually there's some cleanup needed over here. Yeah, maybe. Yeah, I'm gonna try it with the caps as well to see how that works because this has worked much better in the past. But it's not quite the factory efficiency that I wanted. You know, if you were using this method on a factory floor, you had to manufacture like hundreds and thousands of boards a day. This would never cut it. Okay, I think we have pretty good joints there. Last one. Right. I think that gives us a pretty nice set of joints on all these 6 chips. Let me double check with the loop. It's not bad. It's a bit of the solder balls sitting over here, we should probably get rid of. So. Yep. Alright. So those 6 chips are in there. Oh, I should double check the orientation. Yeah, they're all pointing in the right direction. That is good. So I know for sure that these 3 resistor packs were... No, did I know that? No, maybe not. So we have 5 donor chips left, and we have 1, 2, 3, 4, 5, 6, 7 resistor packs to install. So I know for a fact that we should have at least 2 more resistor packs in the box of goodies here. Let's find them. Capacitors. Here we go. Resistor array. 4816P2 221 LF 220 ohm. Oh yeah, solder together VS. These ones look okay, or maybe there are 2 that are connected there. You can test that with a multimeter, see. That is continuity, yes. So let's get rid of that bridge and see if the continuity goes away. And continuity is gone. Yeah, you're a lifesaver. Thank you. This is one of those. It's good to have an extra pair of eyes. Yeah, good save indeed. You know, a big motivation for actually streaming this for me is if I had done this on my own, I would have rushed it so bad. You know, I would have just wanted to finish it in a night and made so many mistakes. So yeah, it's good to have real-time advice and help pointing out mistakes. Still so much reflection, so much glare. Is it this? No. It's probably ceiling light. Oh no, it's probably just the microscope. Now when I think of it. Yeah, maybe adjust the intensity. Something like this. Yeah, for sure. That would have been embarrassing. Alright, here we go. So let's pull this little package open. So here we have a couple of fresh resistor packs, just for science. Let's see. I should really look at the data sheets for these, but I'm too lazy right now. But let's see what happens if we measure the resistance on random pins again. Again, assuming that the input pin is pin number 1. Right here, and then we measure one of the other pins over here. Okay, so pin 1 and 5 measures 0.43 kilo ohms. 0.43 kilo ohms. And it's supposed to be 0.22 kilo. So it's, by that measurement, they measure twice the resistance than spec. I don't know if that's normal for a resistor pack when you measure on pin 1 and 5. I should learn these stuff. I'm just winging it right now. Anyways, these are, according to the factory, 220 ohm resistor arrays. So let's look at the BOM. Here are these 7 interesting. So RP9 is a 200 kilo ohm. RP8 is a 1K kilo ohm. Actually, that reminds me, I did make my own little notes. Let's see if I have something helpful on here. There we go. Nice, I took some notes for myself. Yeah, so RP4 through 6 are definitely these 03000. 0300. So why don't we start with that then, since we know that that's where they should go. And 0412 or 0402 is RP7. Notches there. Silk screen markings looking good. So let's try hot air one more time with this guy. Let's see what happens. This time it seems I need to be quite even. It's so hard to get even. So looks better. Oh, I forgot to clean the pads again. We'll see what happens. Okay, we are heated up. So, so let's try just applying heat from very closely right on top here. Let's see what happens. This is so weird. Yeah, I don't think it should be behaving like this. I wonder if this solder paste is spoiled already. Yeah, maybe. There's oddly little of the solder on the pads themselves, it feels like. You know, it should look like this, right? Yeah, maybe a little bit better this time. But it's kind of stuck in between the legs. It's so weird. Yeah, the joints look alright. Yeah, it should, because I used this stuff before, and you know, it has this very satisfying sensation of the solder just flowing, kind of sticking onto the pads by itself, which is what I wanted to kind of demonstrate, but it's been a bust today. But with cleanup, we got pretty nice joints there, which is helpful. Right. So we have 1, 2, 3, 4, 5, 6 spots left, and we have 6 chips. So let's go with RP4 through 7, 4, 5, 6, 7, which are the O300s. 4, 5, 6, 7. Which are over here. 4, 5, 6, and wait a minute. No, wait a minute. Let's double check. Yeah, 7 is the different one, the 402. Sorry. So 4, 5, 6. These 3 should have one, 2, 300. And 1, 2, SO300. And 1, 2, SO300. Very nice. So let's, this is the last hurrah for maybe for the solder paste approach for this job. Let's do it one more time, see what happens. So what I'll do differently this time is to have a bit more airflow. See if that makes a difference. Maybe like 3 or 4. Okay. So there they are. Since orientation is correct, yes. Switch out. I wish I had more workbench space to keep more than one tool at a time up here, but what can you do? Let's turn it up. Now let's put filter 3. Alright, here we go. Now it's still doing that kind of blob thing. It's very curious. Yeah, I'd love to hear from somebody who has experience working with this to tell me what is wrong. But at least the chip is kind of flowing into the right spots. Like when you apply the air on the side there, it's kind of pushing the chip. Let's add a little bit of airflow. Anyway. Yeah, so we have another middling outcome. This definitely needs some more soldering iron action. By the way, all this solder paste kind of generates a lot of this excess solder that I need to put in the trash. Yeah. It's, as I said, it's worked in the past, so yeah, it's a bummer. Well, this is a, for science, it's a good example of what happens when it's not working. And I'm not too dissatisfied with the actual result, Exactly. For science. Look, that's a lot of excess solder. The nice thing about this solder pass solder is that it's kind of viscous, sticky, so it's easy to pull. Just pull the solder bridges away. You know, you just kind of latches onto the iron. Yeah, I agree. It's not the worst way. You kind of, without this, you'd have to do the whole fiddly thing with first attaching one side or one pin and then kind of take it from there. These are pretty stubborn solder bridges. Let's just get some weak on there. By the way, this week is terrible. This doesn't help. I have the terrible week. Don't get this stuff. This sucks. It's awful. Duratool brand. Garbage. This is the good stuff. Chemtronics. Seems alright. Okay, I think that's enough. Yeah, much better, I agree. So let's get the three last chips on there. Yeah, so I got the advice over at the Tinker Different forums that you do indeed not have to care like the exact resistance value on these resistor packs is not super important. So I have a memory that actually for these new parts I ordered ones that were fairly close in value, but not exact because those don't exist anymore. But first of all, we should find a place for this SO300, and since it's a survivor part, it must come from RP1 over here. On a bridge? Okay, I'll check that in a minute. Let's check if I have some notes on this. RP1, so I didn't make a note of this, that was a mistake. But here it says 22 ohms, which is the same as RP456, which is where we use the other ones of these O300s. So let's put solder, actually yeah, let's take care of that solder bridge as you saw. Pins 2 and 3 on what, the last chip? Don't Oh yeah, yeah, okay, I see what you're saying. That does look like a solder machine. Still there. Okay. Weak time. Now we got the bridge out at least onto the pins themselves. Stubborn. Very stubborn. Okay, now it's gone. Anyway, another good save there. Thank you. Okay. So yeah, after all that, let's just use the iron for this one. Yeah, very beautiful. Indeed, really helps. There it is. Notch is right there. It's not really, did not really attach. Okay, seems better, but let's push it a little bit further. Okay, it's on there pretty nicely. Let's solder the other side. In my experience, it's a good idea just once you've got the first pin soldered like so, don't solder the same side pins first because that may easily melt the solder you've got on there, and then yeah, messes up. So it's actually no, should get some flux on here. Oops, I should not have pushed on the chip like that. That's not good. Bend the pins. Okay. Okay. Looks like the second to last pin there is not on right. So if we can just add more solder. Try to check it with the loop. Yeah, it's on now. It's okay. Let's do the immediate cleanup because this stuff is pretty nasty. Alright, final 2 surface mount ICs in this build. Ah, thank you. Yeah, the last side there went pretty smoothly. Let's clean this up. Two final resistor packs, and these are the ones that are brand new. Let's do this method of one pad. And the reason I'm not doing all the pads at once is, and I explained this in a previous stream, is that if you have all of the pads on one side solder, have a little bit of solder bump on them, then the chip is gonna be lifted up a little bit on that edge, right? Wait a minute. Will these fit on here? Are these the wrong form factor? Yeah, it seems alright. Yeah, I was looking at it from the wrong angle. But anyway, so if you have all of those bumps on there, and you put the chip on top like this, it won't be flush against the board, right? And you won't be able to melt all of those pads at once in order to push it down to be flush against the board. So that's why, yeah, and I'm a bit anal about making sure the chips are flush. So let's see if we can get this on here. Yep, it's on there all right. A little bit of flux there. Let's go in view. It's kind of, the whole thing is floating away. Awkward angle. Sorry about that. It's just kind of a hard angle to work on. Let's do the other side. Looks. Yep, beautifully. That went on there very nicely. And then, there it is. Very last chip. Notch downwards. So this is the FPU sits just next to it here, which is why there's kind of an awkward angle working on it. It's on there, all right. Actually, it's a bit shifted too much in one direction. That's better. I don't know about quickly. I feel like I'm making very little progress. Crap, I keep bumping into the chip. Doing that is not good. Sorry, I was out of focus. Right. Well, it would take longer. Well, once you get a hang of it, things go a little bit faster. But yeah, it's fairly complex in that you have to have the right parts in the right place, assembled in the right order, and get all the pads attached to the line, and no bridges, no missing joints. There are a lot of variables for sure. And yeah. So this one is not, yeah, the right tools, that's important. Alright, here we have it. That's the SE30 reproduction logic board with all the surface mount ICs attached. I think. I don't think there's any of them missing. And yeah, that is it for today, I think. It's lunchtime over here. I need to walk my dog. I need to entertain my wife. And thanks for joining. Thanks for listening. Thanks for the advice, Xenocide 21. See you next time. Bye-bye.